Hello everyone, my name is Martin and today I'm going to teach y'all how to derive the Pythagorean theorem using a square and a segment length. So what I have here is I have a triangle ABC, and triangle ABC is a right triangle. And so we know that if the triangle is a right triangle, then a squared plus b squared equals c squared. And this equation here is known as the Pythagorean theorem. But do we really know how the Pythagorean theorem works? So a bit of background information. So right here we have the Pythagorean theorem up here, and we can understand the Pythagorean theorem better with this equation right here, which is a plus b to the whole squared. And this can be simplified into a squared plus 2ab plus b squared. We'll need this for future information. So right here I have segment A and B, and what I just did is I took a straight edge and I drew a straight line, and I split the segment into two parts, part A and part B. Over here, what I did is I just copied A and B to four sides of a square. So I have A here, B here, A here, B here, A here, B here, A here, and B here. Then I connected the adjacent points. And then after connecting the adjacent points, I realized that I created another square on the inside. Then I labeled the sides of the adjacent square, of the inner square, to be C. So the area of the inner square is now C squared. And what I've essentially done is I created two ways to find the area of the outer square. And the two ways are is a plus b to the whole square, going back to some of the background information that we can use now. And we find that it can be a plus b to the whole square because the area of a square is side times side, and side length of this square is a plus b. And if we just square that, we can get the area. Another way is we could find the area of these fine parts, and then we could add 5 parts, and we can add them together. And the 5 parts can be c squared because of the inner square, and it could be 1/2, 4 times 1/2, a times b. And we get 4 times 1/2 a times b because we have a total of 4 smaller triangles, 1, 2, 3, and 4. And we know that the area of a triangle is 1 times base times height, 1/2 times base times height. So we know the base is b and the height is a. So what I just did is I have 4 triangles, so 4 times 1/2 a times b. And then what I could just do is simplify that into c squared plus 2ab. So here's the two ways we could find it. I just made the diagram here a little bit smaller. So number 1 is a plus b to the whole square, and I can make that equivalent to a squared plus 2ab plus b squared. And I got that because I just used the FOIL method, and I figured out that this expression right here is just equivalent to that. And then the 5 parts of the square will equal square c, and the 4 triangles, which is 1/2 a times b. So now I could do c squared plus 4 parentheses 1/2 ab. So now I just have c squared plus 2 times ab. And then if I carry it over to the back, I have a squared equivalent to that, and I have c squared is equal to a squared plus b squared, because I have a squared plus 2ab plus b squared is equivalent to c squared plus 2ab. And I realized that they have a common expression among both of them, which is 2ab. And then if I just subtract that out, I get c squared equals a squared plus b squared.